This is one of Europe's biggest construction sites, perhaps even the biggest. Hinkley Point C is the first nuclear power plant the UK has built in decades, and it's set to usher in a whole new generation of energy infrastructure for the country. But it's been beset by huge delays, environmental disputes, and cost rises, to the point where it's now expected to become the most expensive project of its kind ever constructed. And with other schemes due to follow its blueprints, the pressure is now firmly on to finish the job. This is the story of Britain's divisive nuclear megaproject, a spectacular feat of engineering at risk of being overshadowed by controversy. In the mid-1950s, after the horrors of Hiroshima, three nations began a race to develop nuclear power for uses other than bombs. The Soviet Union was the first to generate electricity with atomic energy in 1954. 3 years later, the US unveiled a full-scale nuclear power plant dedicated to peaceful purposes before anyone else. But in between, the UK made its own piece of history.
There's nothing like it anywhere in the world. Neither Russia nor the United States is yet creating electric power on this scale from the atom.
At the Calder Hall power station in northern England, atomic energy was used commercially for the first time, although its main purpose was to make plutonium for nuclear weapons. Still, that meant the UK was once a pioneer in the field of nuclear, which continues to be a major source of energy well into the 21st century. So surely then, its mission to construct a brand new nuclear power plant has gone swimmingly. Well, not exactly. It's taken much longer to build and become way more expensive than was originally predicted. The project has also gotten extremely complicated and pretty chaotic. However, delivering 2 new nuclear reactors after not building any for a very, very long time is challenging to say the least. You see, right now there are 9 nuclear reactors operating across the UK over 5 different sites. Together, they generate around 13% of the country's electricity, but many of them are nearing the end of their lifespans based on old technologies and are either due to be decommissioned or have already started the process. 6 have been shut down in the last few years, and there hasn't been a new power plant built here since the 1980s. And yet, that doesn't mean the UK's given up on nuclear completely. In fact, it's quite the opposite. It now plans to build as many as 8 new reactors between today and 2050. Now, 2050 might sound like a very long way off, but Hinkley Point C is providing a quarter of those new reactors on its own. As you can see, this project is simply enormous. The spot where it's being built, on the south bank of the Bristol Channel in Somerset, England, is widely considered to be Europe's largest construction site. Spanning 430 acres, it dwarfs the plants beside it, Hinkley Point A and B, both of which were built in the 1950s and 60s and are now closed. When complete, Plant C will produce 7% of the UK's electricity, enough to power around 6 million homes for 60 years. But how is it all coming together, and what even are the main components of a modern nuclear power plant? Well, first of all, it's important to kind of understand the basics of where all that power is coming from. Yes, we're talking about the reactors. To put it simply, it's part of the system where uranium atoms are split apart through a process called fission. That creates heat, which converts water into steam. Next, the steam is used to turn a turbine, generating electricity. Now, as if building the first British nuclear power plant in over 30 years isn't a big enough challenge, it's also the first time that EPR reactors have been used in the UK. Now, EPR stands for European Pressurised Water Reactor. They've already been deployed in other areas of the continent, at Flamanville in France and Olkiluoto in Finland. Both of those are new and were built by EDF, the energy company now fully owned by the French government, which just so happens to be in charge of Hinkley Point C. These reactors use 17% less uranium than older technologies and have 4 safety systems to protect against hazards like floods and earthquakes. Not that we get many of those in the UK, but it's better to be safe than sorry. Now, before we get into the construction details, have you ever thought about becoming the sort of engineer that works on mega projects like this? If assembling nuclear reactors sounds like the right career for you, then this week's video sponsor Brilliant has all the tools you need to get started. With Brilliant, you can develop your critical thinking skills through problem solving instead of memorizing. You can choose from thousands of interactive lessons in subjects like data analysis, probability, programming, and coding. But it's Brilliant's comprehensive range of math courses that are especially useful for nuclear engineering newbies. Designed for users of all levels, you can learn how to build and apply formulas or boost your knowledge of algebra and calculus. And you can take as much time as you need. If you want to learn just a little more each day, it's entirely up to you. To try everything Brilliant has to offer for free for a full 30 days, visit brilliant.org/the B1M or click the link in the description. You'll also get 20% off an annual premium subscription. Now, let's get back to that enormous power plant and try and decipher where you'll actually find the reactors at Hinkley Point C. Well, they're located in the reactor buildings, and you can't really miss them thanks to their enormous size. Like almost every structure on this site, a great deal of machine power was necessary for their construction. In fact, because so much of the build requires massive segments to be moved around simultaneously, there are cranes everywhere, more than 50 of them at a time, including one that stands out from the rest. Meet Big Carl, the world's largest land-based crane. Carl's been used for a number of heavy lifting tasks, including putting the dome onto the first reactor building and placing the giant liner rings, which weigh hundreds of tons each. There are 3 of them on each unit, and together they form part of the inner containment wall. Once in position, they're encased in 2 layers of concrete. Vast amounts of the material was needed overall, 25% more than on the power plant's Hinkley Point C was modelled on. 9,000 cubic meters of the stuff was poured in one go for the base of the first reactor, beating a record held by London's Shard. Now, that's because British regulations required a number of changes compared to those on the sites in France and Finland. And when I say a number of changes, I don't just mean a small number. In fact, 7,000 alterations were carried out to make this place compliant. As well as all that extra concrete, 35% more steel was put in. But as you might have guessed, adhering to these rules became more time-consuming than originally thought and contributed to some major delays. As for the reactor itself, the main component, the pressure vessel, was delivered in 2023 and installed in late 2024. The giant steel container, which will hold the nuclear fuel, was first lifted onto rails and inserted through an equipment hatch. Then, once inside the reactor building, it was gently rotated and lowered into place. Surrounding each of these vessels will be 4 steam generators, 25 meters long and weighing over 500 tons. After 6 years of design, manufacturing and testing, the first one was delivered to site in May 2024, following a journey from northern France across sea and road. Just next door to the reactor buildings are the absolutely enormous turbine halls. 50 meters tall, these are going to house the largest turbines of their kind anywhere in the world. Now, it doesn't look much like a finished power plant yet, but with so much activity on site, you'd be forgiven for assuming that this thing must be getting pretty close to the end. But you'd be wrong. It probably won't be operational until at least 2029, and that's with just one of the reactors running. Full power is now expected in 2031. But that wasn't the original plan. When contracts were first signed back in 2016, the original plan was to complete the whole project in 2025. And as is often the case in these situations, the price tag has gone up substantially.
It will cost as much as £10 billion extra to build the plant, over €11 billion.
What was due to cost £18 billion when it was first greenlit could end up as high as $46 billion after inflation. That works out at more than $57 billion, considerably higher than what was spent on the new reactors at Plant Vogel in the US, which had their own share of problems. The costs have gotten so high at Hinkley Point that it's now on track to be the most expensive nuclear power plant ever constructed, and by some distance. According to EDF, there are a number of reasons for this. It's been hit by labour and material shortages, COVID caused over a year of delays, and then there were those regulatory changes we talked about earlier. Training up the workforce and forming supply chains in a country that hasn't built one of these for a generation has taken a lot longer than planned. Another concern has been the environmental impact, and it's not all to do with nuclear waste. Of course, that has been an issue for many people, and the plan is to ultimately store the waste hundreds of meters underground in a new type of specialised facility. Instead, a lot of the backlash is actually to do with fish. You see, nuclear power plants require huge amounts of water to keep their reactors cool, and they have to get it from somewhere. To ensure there's enough water for Hinkley Point C, 8 kilometres of tunnels have been built connecting the site to the Bristol Channel. These are going to allow up to 120,000 litres of water to be transferred every second. The problem is, the channel is full of fish, so there's a danger that many are going to get pulled into the system by accident. Because of this, EDF is planning to introduce a fish recovery and return system. Then there was a requirement from the Marine Management Organisation to install an acoustic deterrent. This would essentially blast sound underwater to scare fish away from the intakes. EDF isn't too keen on this idea, calling it dangerous to install and unproven, which is why they've put forward an alternative, creating new salt marshes in the surrounding area. EDF says these are going to provide breeding grounds and shelter for all kinds of wildlife. This, they claim, will make up for the fact that they might be sucking tons of fish out of the water every month. But that decision's come under fire too. Because hundreds of acres of land would have to be flooded to form these habitats, some local farmers have objected to the idea alongside the local council. But with a project like Hinkley Point C, it's all about perspective. Yes, what's happened so far hasn't been a roaring success, but building something this complex after so long was never going to be easy. Looking forward, there is some cause for optimism. EDF believes the worst is behind them and that they've learned the lessons from the setbacks they faced on the first reactor. Teams are using the lessons learned on Unit 1 to make the construction of Unit 2 20 to 30% more efficient. For example, they're now able to weld together the massive steel pools 4 times quicker than before. Their job is to house the reactor and shield against radiation. Another thing that makes this so important to get right is what's in the pipeline after this scheme is finally wrapped up. EDF is currently getting ready for its next UK plant, Sizewell C in Suffolk. That'll be a virtual replica of Hinkley Point C, and you can be pretty sure the company is going to want to avoid making similar mistakes again. With the UK planning to quadruple its nuclear capacity by the middle of this century, the country can't really afford a repeat of this project's complications. And yet, when you really look at what's being built here, it truly is an astonishing feat of construction. As one of the birthplaces of atomic energy, the UK's lack of nuclear progress is somewhat surprising. But with Hinkley Point C, it's looking to regain some ground on an epic scale after what's been a difficult journey. It's the biggest energy decision this country has made in decades, but whether it'll be looked back on as a good or bad choice in years to come remains to be seen. This video was sponsored by Brilliant. You can learn more about that at the link below. Don't forget that we're raising awareness of construction's mental health crisis and supporting charities in this space through our Get Construction Talking initiative. You can learn more and find links to support over at getconstructiontalking.org. And as always guys, if you enjoyed this video and you want to get more from the definitive video channel for construction, make sure you're subscribed to the B1M.